Hey everyone, welcome back. Today we are diving into a super important topic in C++ and programming in general. Stack versus heap in memory management. Let's break it down step by step. First, let's talk about the stack. The stack is a region of memory that stores temporary variables created by each function. Think of it like a stack of plates. You can only add or remove a plate from the top. Similarly, in memory, the last variable you created is the first one that gets removed. In C++, when you declare a variable inside a function like this, the variable x is stored on the stack. When my function ends, x is automatically removed from the memory. You don't need to do anything. This is called automatic storage. The stack is super fast because it only has to move a pointer up and down. But there is a catch. The stack is small. If you use too much stack memory, you can get a stack overflow. Now, let's move on to the heap. The heap is a region of memory used for dynamic memory allocation. You manage it manually. If you need a variable to live beyond the scope of a function or you need a large amount of memory, you use the heap. In C++, we use new to allocate memory on the heap. Here, p is a pointer stored on the stack, but the actual integer it points to, the 20, is stored on the heap. Important difference. When you are done with heap memory, you have to free it manually, using delete. If you forget to delete, you have a memory leak, which can cause your program to eat up memory over time. One way to visualize this is, the stack memory is like a stack of plates, where you always remove or add plates at the top. Heap memory is like a big storage room where you can throw stuff anywhere, but you have to remember to clean up after yourself. Now, let's look at a quick comparison. The stack is fast but small. The heap is slower but much larger. The stack memory is automatically managed. The heap memory must be manually managed. Another thing to keep in mind. Accessing heap memory is slower than accessing stack memory, because it involves more steps for the CPU. In real-world C++ code, you try to use the stack as much as possible, because it's efficient. You only reach for the heap when necessary. There are also smart pointers in C++, like stud unique pointer and stud shared pointer. These pointers help manage heap memory automatically. Here is an example. In this case, smart p will automatically delete the memory when it goes out of scope. You don't have to manually call delete. This helps avoid memory leaks and makes your code safer. Another important point. When you pass variables to functions, stack variables are usually passed by value, making a copy unless you use references. Heap allocations are typically passed around using pointers or smart pointers. Quick tip. If your object is small and doesn't need to survive outside the function, use the stack. If it's large or needs to live longer, use the heap. To wrap up, stack memory is like a quick, short-term storage. Heap memory is like a long-term storage, but you are responsible for managing it. Understanding the difference between the stack and the heap will make your C++ code more efficient and bug-free. Alright, that's it for today. If you found this helpful, don't forget to like and subscribe for more C++ content. See you next time.